So recording now. So this is the example from the last lesson. We had a circle, had a diameter of 20 meters, which we realized therefore means the radius is 10. Find the size of the central angle, subtended, which comes from an arc of length 30 meters. So we thought let's use the nice little radians formula, because the radians formula is super easy. And let's find the angle in radians. So for an arc length, the formula for radians in the formula booklet was L equals theta r, and we know the radius is 10, and we're told that the arc length is 30. So all we do is sub in 30 for the arc length, sub in 10 for the radius, and then solve to find theta. And we got theta equals 3 radians, and that's where we were up to end of last lesson. Then that's all good. Now all we had to do was convert your answer to part A into degrees. How would you convert that thingy into degrees? Sometimes if you've got your way of doing it and it works, life's great. My way of doing it, which I just like to start with, any conversions between radians and degrees, I write out my reference. Pi radians equals 180 degrees. I write out that little reference. The board just became uncalibrated again, so I'll just quickly calibrate it. So that was pi radians equals 180 degrees. That's our little reference. And we've got to convert 3 radians into degrees. So I would write here 3 equals x degrees. And remember, we can set these ratios up, and we can set it up as a fraction. So that says pi radians equals 180 degrees. 3 radians, which was our previous answer, equals x degrees.
Oh! And you don't write 3 radians because radians just cancels out with this one.
Yeah, exactly, yeah. So you could,
that's what I was not understanding yesterday.
So you could write radians if you want there. But yeah, you don't need to. I just set it up like that. So pi over 3 equals 180 over x. Still do that. Nice colours. Okay, pi over 3 equals 180 over x. And then you can cross multiply and solve. So maybe let's make a note. Cross multiply and solve. Cross multiply and solve. So pi times x is just pi x. 180 times 3, maybe let's just show that working out, just so you can look back and see how you're getting these numbers.
Is it 54?
540, I mean? Yeah, good, exactly. So x equals 540 divided by pi degrees. That's not a horrible way to leave your answer. If you really want, you could write 540 over pi degrees, or you could work it out on a calculator if you want to know it. So what is 540 divided by pi?
171.86733, blah blah blah. 172 degrees.
Yeah. Okay, 172 degrees, yeah. If you were asked to just leave, if it was non-calculator, so if that was non-calculator, I would have just left it as 540 over pi degrees. So if it was non-calculator, you can write 540 over pi degrees. So assume that one was with calculator. So on the non-calculator practice questions I just handed out, you'll notice some of the answers are written just in terms of pi, like the answer might be 3 pi plus 40, or 2 pi divided by 7, something like that.
Who made this practice question? Is it Miss Harrison?
Miss Harrison, yeah, she got them from some past exams.
Who does she teach?
She teaches there's 3 SL groups, and she teaches one of them.
Really? I didn't know she did 12 grades.
Yeah, she does.
I kind of did. I'm sure that's something.
Yeah, Miss Kelly's took over Mr. Potts's class. So the 3 years. Yeah, that's right. He's gone to Summersfield.
Oh.
And so yeah, it's very cool. Okay, let's move on to you. So we have. Oh, right. So were there any questions about that though? Was anyone writing that down? Sorry, I just moved. Okay, 172. Or if it was non-calc, you'd write 540 over pi and then just write degrees next to it. This one is just like one in your topic assignment, it turns out, which is pretty exciting. In a circle, notice I've given you the arc length is 7.8. That's fab. And the area of the sector is 31.2. Find two things. You've got to find the central angle and the radius. I'll give you a little clue. It's going to be easier to find the radius first, and I'll show you why. We don't know the radius or the angle at this point, but we know there's a nice, if you're talking about radians, there's a really nice, beautiful, simple formula.
I mean, they are.
Theta r, yep. And there's a nice, simple formula for area of a sector, and you'll find that you can divide one by the other, and the theta will cancel out, and the r.
That doesn't sound so bold.
Yeah, I would have been hard at first. It'd be hard at first.
What did you say, Paige? You mean sarcastic?
Exactly.
You mean sarcastic?
No.
Oh, good. That's nice. So arc length. So the arc length formula, theta equals, L equals theta r, sorry. And the area formula, area is, remember, a half theta r squared. Don't be like me and by accident sometimes write a half theta squared r. If you're in doubt, just look at the formula. Half theta r squared. Area.
But why would you divide it?
Yeah, exactly. Before I do any dividing, I'm going to sub in that the arc length is 7.8, and I'm on the next going to sub in 31.2 centimeters squared for the area. I'm going to do that. 7.8 equals theta r. 31.2 theta r squared. So this is a nice, beautiful looking formula. 7.8 equals theta r, beautiful and simple. 31.2 equals a half theta r squared is not quite as simple as I'd like at first. I'd rather, let's just maybe get rid of the half so that we're just left with theta r squared. What would I do to both sides?
Divide 2 or multiply by 2.
Multiply by 2, exactly, yep. Either divide by a half, which is the same as multiplying by 2. So what is 31.2 times 2?
62.4.
Yeah.
Whoa,
62.4.
mathematician.
So I'm just going to circle those because they're ready. Two beautiful, like remember simultaneous sort of equation kind of things? They're almost simultaneous. If I take the green one and divide it by the yellow one, what's theta r squared divided by theta r going to cancel down to? R. Yeah, it's going to just cancel down to r. So that's what's awesome about dividing the area formula by the green one by the yellow one. You'll be able to solve for the radius. So yeah, 62.4 and then theta r squared over here over 7.8 theta r here. As we said, the thetas are going to cancel down, and the r squared divided by r is going to cancel just down to r. Does anyone happen to know 62.4 divided by 7.8? It's just a nice whole number. Yeah, it's 8. So we tried to give you numbers that are going to give you a lovely whole number. So you've got the radius. So maybe because it's a question, so r equals what? Do we have any units?
Centimeters squared.
Centimeters, yeah. So notice I wrote 8 equals r, so maybe r equals 8 cm, just to make sure that that's our, that's our radius. So we're partly answered. We found our radius. That's why I suggested find the radius first. And what's awesome is you can just plug the radius into either the area formula, the green one, or the yellow one, to solve for the theta. So just pick whichever one is easier, do you think? The yellow or the green?
Yellow.
Yeah, it's just got less stuff, doesn't it? Well, you could, if you prefer, you could put in r squared, it's 64, and 62.4 divided by 64. They're probably as easy as each other. I personally think just subbing in to the yellow one. It's my favourite way. So let's make a note of what we're doing. Now substitute r equals 8 into the arc length formula. Or it could be the area formula to solve for theta. So just making it. Okay, so theta. So just solve for theta. And have I given you much space? Okay, good. So it was 7.8 equals theta r. If you want, just remind yourself what it was. Yeah, 7.8 equals theta. And we know that the radius is 8. So we're just plugging it into the yellow formula above. To solve for theta, what would I do? Page. Would I times by 8? By 8. 7.8. I'm running out of space, so I'll just do it in a sloppy way. I'll just do that. Yeah, weird number, but it's right. Key. Yes, sure. 0.975 radians. And that's good. How did you know that the answer was in radians and not degrees, Paige?
The next question.
Yeah. Oh, there's always that, yeah. Yeah, it kind of gives it away a bit, doesn't it? But in particular, the reason... Yeah, exactly. It's because we use the formulas for radians. We use the arc length and area formula for radians. So that's why our answer's in radians. If you want to make a note of that, feel free to say it's in radians because we use the arc length and area formula for radians. And then convert to degrees is just like how we do the other one. You have your own way that makes sense to you is fine, as long as you're getting your right answers. Pi radians equals 180 degrees is my little reference. And we can put 0.975 is x in. Then I just find I don't have to think as much. I sort of just write my reference one, put the unknown, make sure we've got degrees on degrees, radians on radians, turn it into two little fractions. Yeah. Pi. Oops. Pi over 0.975. Get rid of that now. Equals 180 over x. See that? Oh, let's undo that. That blue thing there is messing this up. And then we cross multiply and solve for x. And we'll be done. So if you want to make a note again, you can cross multiply and solve for x. And then you probably get something like pi x equals 180 times 0.975. What is 180 times 0.975? Is it?
Yeah.
Is it? Oh, I think you're looking at your previous page. Page 25.
Oh.
Yeah, that's it.
175.
Yeah. Yeah, because 540 was the previous one. Yeah, and that's an awkward number. Like if you were to write an answer in terms of pi, if it was non-calculator, the only issue with that answer is that you're not supposed to really have a decimal in the fraction. So you could double the top and double the bottom, and it would be fine. Then you would get something like 351 over 2 pi. If that was a non-calc, but if it's with calc, you just say what the calc. What is the calculator answer, Sarah? Like 50 something. 55.9 Can anyone work that out in that spooky looking writing? That's 55.9 degrees. Again, if you, as I said, if it was non-calc, if it's with calc, that's fine. Do this. If it was non-calc, you're probably not supposed to leave an answer like this because you're not supposed to have a decimal in a fraction. So you would double the top, double the bottom, and then that would give you 351, I think, over pi. degrees if it was non-calc. And that's the end, and now it's topic assignment time. Where's it gone? Shall I stop now?
Yes, you shall.
One second.